My dear students, I hope all of you are fine. In this lecture, let us look for the solutions of the questions which were asked in NEET exam so far. The common question which were asked in the NEET exam is, what is the dimensional formula of thermal conductivity? Our question may come in this way: what is the SI unit of the thermal conductivity? So first let us derive the dimensional formula of thermal conductivity. After that we will look for the SI unit of this thermal conductivity. As you know, thermal conductivity is basically the rate of flow of heat per unit area per unit temperature gradient through a solid. And you know, if the value of thermal conductivity for a solid is large, that solid is good conductor of heat. And if the value of this thermal conductivity is small, it is less, then that material or that solid is good thermal insulator. So thermal conductivity will reflect only the conductivity of the material. If its value is large, that material is good conductor of heat. If its value is small, then that material is poor conductor of heat and acts as a thermal insulator. As we know, we will use the formula since we know what the rate of transfer of heat delta Q divided by delta T is equal to K. Here K represents the coefficient of thermal conductivity. A, that is the area, into delta T divided by delta X. This here represents the rate of fall of temperature, that is the temperature gradient. So we have this formula. So from this formula we can calculate the thermal conductivity, the coefficient, the dimensional formula of thermal conductivity. This here represents the rate of flow of heat. So LHS represents the rate of flow of heat. Okay. K represents here the coefficient of, I will write here as coefficient of thermal conductivity. Coefficient of thermal conductivity. Okay. A here represents the area of a solid. Okay. Delta T divided by delta X represents the temperature gradient. So here it represents the temperature gradient. Temperature gradient. So with the help of this formula we can calculate the SI unit of this thermal conductivity or the dimensional formula of this thermal conductivity. So from here I can write K is equal to delta Q divided by delta T whole divided by A into delta T divided by delta X. Now looking for the dimensional formula, as you know, the K here is equal to delta Q. Here represents the amount of heat transfer that takes place through a solid. So delta Q here represents the heat, and you know the dimensional formula of heat. Heat is a form of energy. So its dimensional formula is m L square T minus 2. This is the dimensional formula of delta Q. Okay. Divide by delta T. So delta T here represents the time. And you know, the dimensional formula for the time is T. Okay, clear? Divide by area. The dimensional formula for area is length square, L square, into delta T. Here it represents the temperature, delta T. So it is represented by K, Kelvin. Its dimensional formula is K. Divide by delta X. Delta X here represents the thickness of the solid. So this is the distance. So its dimensional formula is L. It represents the distance. Okay. Now continuing this thing here, the dimensional formula for coefficient of thermal conductivity K is equal to, now it is m L square T minus 2. So here we have a T. In the denominator, let us take into the numerator, it is T minus 1. Whole divided by L square into K divided by L. Now L and L goes, so it is K is equal to m L square T minus 2 T minus 1 divided by, here we are left with 1 L, so it is L into K. Now again 1 L and the L will goes out. So K is here equal to m. Here we have L, T minus 2, T minus 1. Bases are same, powers are added. So it is T raised power minus 3 divided by K. So this K is here, the Kelvin. So the coefficient of thermal conductivity K, its dimensional formula is m L T minus 3 K minus 1. This is the dimensional formula of coefficient of thermal conductivity. And the dimensions are 1, the power of m1, the power of L1, power of T minus 3, and the power of K minus 1. And because you know, dimensions are basically the powers which are raised to the base quantities in order to represent the dimensional, in order to represent the physical quantity. Okay, so this is the dimensional formula of coefficient of thermal conductivity. It is m L T minus 3 K minus 1. Now looking for the SI unit. The SI unit of thermal conductivity. Again, I will write here, since we have what? Since we have delta Q divided by delta T, that is the rate of transfer of heat, it is equal to Ka into temperature gradient delta T by delta X. Again here we can write, therefore K is again equal to delta Q divided by delta T whole divided by A into delta T divided by delta X. Okay. Now you people know delta Q by delta T. So rate of flow of heat. So heat is measured as joules, T seconds divided by area meter square, temperature gradient delta T, temperature is measured in Kelvin, delta x distance is measured in meter. So again here meter and meter goes out. So K is equal to joule per second, it is watt. So W divide by, here we are left with 1 meter because meter and meter cancel, it is meter square, 1 meter will retain here. It is M meter into Kelvin. So the SI unit of coefficient of thermal conductivity is watt per meter per Kelvin. This is the SI unit of coefficient of thermal conductivity. Maybe it is asked in the NEET exam. So we derived the dimensional formula of coefficient of thermal conductivity and we derived the SI unit of coefficient of thermal conductivity. Now looking for the question second, it is if L, Q and R represents the inductance, the charge and the resistance, then the units of QR by L will be those of current, or QL by R will be those of current. Options are on screen. This question includes the concepts from 12th syllabus. So the question is, if QLR, if QLR represents here, so the question is if LQR, if LQR represents the inductance, so L is the self-inductance, it is represented by L, self-inductance is represented by L, so it is inductance. Inductance is the opposition basically. Okay. Q, it is the charge. R, you know, it is a resistance. Now the question asks, the units of QR by L will be those of current, or QL by R will be those of current. Let me check it. First of all, let us find the dimensional formula of this inductance, right? As we know, I told you people that this question includes the concepts from the 12th syllabus. So we know the EMF induced E, it is equal to L di by dt in magnitude. So in magnitude, the EMF induced is equal to L. This L represents the inductance. Di by dt, rate of change of current. So from here we can calculate the dimensional formula of L. First we need the dimensional formula of L. After that we will find what the question asks. So L is here equal to E into dt divided by di. So di here represents the change of current in the time interval dt. E represents the EMF induced. Now you people know EMF induced, right? So I will write here L inductance, it is equal to EMF induced, it is work done on a charge. So W by Q, work done in moving a charge, that is basically the EMF, into dt divided by di. Now deriving the dimensions of this L, therefore the dimensional formula for inductance L is W, so W is work, its dimensional formula is mL square t minus 2 into dt, the time dimension is represented by capital T, divided by Q. So the dimensional formula for charge is AT divided by di represents the current, so it is represented dimensionally by A. So L is here equal to this T and this T cancels out, so it is M L square T minus 2 whole divided by A whole divided by A. Now you know, let us divide this A by 1. It will undergoes reciprocal. So it is ml square t minus 2 divided by A into 1 by A. Now the dimensional formula here comes out to be equal to ml square t minus 2. A into A, it is A square. Now shifting this A square into numerator, what we get, let me write it here, what we get. So dimensional formula for inductance, L is equal to m L square t minus 2. So shifting this A square to numerator, it is A minus 2. So this is the dimensional formula of inductance. Now according to question, if LQR represents the inductance, the charge and the resistance, then the dimensional formula for resistance are, you know, the dimensional formula of resistance can be calculated from the Ohm's law, that is V by I, while V represents the potential difference and I represents the current. Already you people know the potential difference, this is work done on a charge, W by Q divided by I. So its dimensional formula is, the dimensional formula of work is ml square t minus 2 divided by the dimensional formula of charge is at whole divided by the dimensional formula of current is A. So dividing this by 1, the denominator undergoes reciprocal. So R is here equal to m L square t minus 2 divided by AT into 1 by A. Now the dimensional formula of resistance is now ml square t minus 2. A into A, it is A square into T. Now shifting this denominator to the numerator, let us shift this denominator to numerator. So the dimensional formula of resistance is now equal to m L square t minus 2. Shifting this A square, it is A minus 2. Shifting this T, it is T minus 1. Now R is equal to m L square t minus 2. So t minus 2 and t minus 1 into A minus 2. Now here bases are same, powers are added. So dimensional formula for resistance is m L square t minus 3 t minus 2 minus 1. Bases are same, powers are added. So minus 2 minus 1 is minus 3 into A raised power minus 2. This is a dimensional formula of resistance. Now according to question, if L, Q and R represents the inductance, the charge and the resistance, then among the given options, which option has a unit same to that of the current? Now according to question, let us first look for the ratio QL by R. So first let us look for the ratio Q R by L. Now you people know Q is here charge, R is here resistance, and L is inductance. So this is the ratio, and we have to check whether this ratio has the unit same to that of current or not. So it is equal to charge. The dimensional formula of charge, you know, it is A into T. Into the dimensional formula of resistance, it is here M L square T minus 3 A raised power minus 2. So whole divided by inductance. The dimensional formula of inductance is this. It is M L square T minus 2 A minus 2. Now you can cancel out the similar terms. See, M and M cancel out, L square cancel out, A minus 2 cancel out. So we are here left with the terms A, T and T minus 3, and in the denominator we have T minus 2. Shifting this T minus 2 to the numerator, it is A, T minus 3, T minus 2. Shifting this denominator to the numerator, it is T square. Now, it is equal to A. Here, bases are same, powers are added. It is T raised power 1 minus 3 plus 2. You can check here, it is A into T. So, A into T. Then we are left with the T minus 3. So, T minus 3. In the denominator, we have T minus 2. Okay, continuing this thing here. It is A. So T raised power 1 minus 3 plus 2. Now you people know it is T raised power 1 plus 2, it is 3. So 3 minus 3. So it is A into T raised power 3 minus 3 is 0. Anything raised power 0 is 1. So we are left with the A. And you know A is the dimensional formula of current. So current is represented by a letter A dimensionally. Therefore, this ratio QR by L has a unit similar to that of the current. So this represents the current simply. This ratio represents the current. So according to question, the units of QR by L is similar to that of the current. So this option is the correct option.